Welcome to the second test of the Math Open. Question number 1. How many calories will I eat on Thanksgiving if I have 2 helpings of turkey, 3 stuffing, 1 green bean casserole, 2 cranberry stuff, and 4 pecan pies, 4 pieces of pecan pies? Well, we can make a table that shows we have turkey, where I have 2 helpings, and each has 140 calories. Green bean casserole, I have 1 helping. Each helping has 225 calories, and on and on and on. If I multiply that out, 2 times 140 is 280. 1 times 225 is 225, and on down. I can add all those up, and I get 2,414 calories. That's a lot of food. Question number 2. Your average soldier gets to see his or her family 50 days a year. Over the course of a 4-year military career, how many days does a soldier not see his family? Well, let's see the total number of days over 4 years. It's 4 years times 365 days gives you 1,460 days. Actually, it's 1461 if you count a leap year, but let's just keep it at 1460 so it's simple. Now, we just said that your average soldier gets to see his or her family 50 days in those 4 years, so we can multiply that out. That's 200. But we want to know the number of days he or she does not see family. So we can subtract those two numbers, and you get 1,260. Thank you, every veteran out there. We know the sacrifices you make are tremendous, and we so appreciate everything you do. Thank you, veterans. Question number 3. How much does Disney World make in a day? Every day, 10,000 people come to the park, and the average ticket is $105. 60% of those people eat at the park, spending on average $9, and 20% of those people get a souvenir at the park, spending on average $23. So similar to question number 1, let's make a table where we have the number of people, the dollars per person, and the total dollars. So for tickets, we have 10,000 people who each spend $105, so you can multiply that, and you get $1,050,000. Now, food's a little harder. I made it a little trickier. I didn't tell you how many people there were. I told you 60% of the people ate food. So you can take 60% of that $10,000 and get 6,000, or I'm sorry, 60% of those 10,000 people and get 6,000 people. Now notice here, here's 60%. We need to convert it to a decimal, and this is such an important skill. Know how to convert a percentage to a decimal, because your calculator really doesn't do well with percentages. It does do well with decimals. So we have 6,000 people who each spend $9. That's $54,000. And souvenirs, same thing. We have 20% of our people. Again, we convert 20% to a decimal. 0.2 times 10,000 is 2,000 people get souvenirs at $23 a piece. Is $46,000. If you add all those up, every day Disney World makes $1,150,000. Actually, I bet it's quite a bit more than that, but for our problem, that's what it was. Question number 4. You guys are all super good at math, so maybe when you go to college, you'll study STEM, and if you do, on average, you'll make about $60,000 a year. Now, I have no doubt that each of you is going to be an absolute rock star when you start working, so you'll get 5% raises every year. If that happened, what would your salary be after 5 years? Well, you can start at $60,000, and you can calculate your raise. Your raise would be $60,000 times that 5%. Remember, we talked about converting percentages into decimals. Here it is again. 0.05 is 5%, and if you multiply that out, you'd get a $3,000 raise. And then your new salary would be $60,000 plus a $3,000 raise is $63,000. You could do it in one step by taking 60,000 times 1.05 gives you 63,000. Same thing. You can see all the numbers match. Now, this is after 1 year. After 2 years, you take that 63,000, put it back here, and multiply that by 1.05, and you get 66,150. That would be your salary after 2 years. After 3 years, you could do the same thing, and on and on and on. We wanted to know what that was after 5 years, and the answer is 76,577. And basically what we did is we took 60,000 and multiplied it by 1.055 times. Now, hopefully that starts to look really familiar to compound interest. And that button, the X to the Y button, does this exact same thing on your calculator. Multiplying something by 1.055 times is like pressing 1.05 X to the Y 5. And if you do that, and then multiply that by 60,000, you'll get that same answer, $76,577. Now, question number 3, I kind of made up the numbers. Here on question number 4, these are pretty accurate. It's not to say every person who studies STEM in college will make this type of money, but on average, these are pretty close. If you want to make a lot of money, I know money's more important to some people than others, but if it's important to you, studying STEM is a great way to make a lot of money. Question number 5. Here's our compound interest problem. You knew it was coming. Now this is a twofer. You get 2 problems for the price of 1. Adam saves $500 at 7% interest for 20 years. His younger brother Pete starts 5 years later. If Pete can get the same return Adam got and wants to end with the same amount of money that Adam ended with, how much does Pete need to start with? So first we need to do Adam. Now, like every single time we do these problems, hopefully you've memorized this equation. Compound interest is what you start with times 1 plus the interest rate raised to the number of years equals what you end with. So for Adam, we know we start with $500. He has a 7% interest rate. He invests it for 20 years. What does he end with? We can put that into the equation. 500 times 1.07 raised to the 20 equals $1,935. Now we're on to Pete. Pete's a little different, right? We don't know what he starts with. That's what we need to figure out. We know he gets the same interest rate, and we know instead of 20 years like Adam had, he only has 15 years, and he wants to end with the same amount of money that Adam had, $1,935. If you put that into the equation, you don't know what the start is. You multiply that by 1.07 raised to the 15, and you know what it ends with, 1935. So the first thing we can do is we can figure this out. If you take 1.07 raised to the 15, you get 2.759, and then this just becomes an algebra equation. You can divide both sides by 2.759, and you get $701, and that's your answer. Pete would need to start with $701 to get as much as Adam got if he waits 5 extra years. Question number 6. This was probably the hardest question we've ever asked in one of these Math Open tests. A regatta has 12 boats racing each other. What is the probability of you correctly picking the top 3 finishers? It doesn't matter what order you pick the top 3 in, just so long as you get them in the top 3, and assume the outcome's random. All right, so here are 12 boats, A, B, C, D, E, F, G, H, I, J, K, and L. 12 boats. And let's assume that the actual top 3 finishers were G, B, and E. What's the probability of you picking G, B, and E? Well, like we do with a lot of these problems, let's break it down into simple steps. What's the probability that your first pick is right? That the first pick you make is one of those top 3 finishers? Well, there are 3 top 3 finishers, and there are 12 boats you can pick from, so it's 3 12ths. Hopefully that one was pretty easy. Now it'll get a little trickier. What's the probability of getting your second pick right? It's not going to be 3 12ths because remember, in your first pick, you already picked one of the boats. So let's say in your first pick, you picked B, which ended up being right. In your second pick, you can't pick B anymore. So it's not going to be 3 12ths. You only have 2 picks you could make now, either a G or an E. And instead of 12 boats to pick from, you only have 11. So the probability of getting the second pick right is 2 out of 11. The probability of getting the third pick right is similar. It's not going to be 2 out of 11. It's going to be 1 out of 10. So this is the probability for each step. Now remember, we want to do all these together. What's the probability of all 3 of these things happening together? We can multiply all these fractions out. 3 over 12 times 2 over 11 times 1 over 10. If you multiply all those out, it's 6 over 220. And you can make that into a fraction which is 0.45%. This is a hard question. I'm not lying to you. And for all of you who got it right, congratulations. There are, this would be hard for some college kids and for a lot of adults who work with numbers. If you can get this right or understand these concepts as a fourth or a fifth grader, the world will open its doors to you, and you will have choices, any choice you want professionally. It's just amazing if you can start understanding probability in this way. It's so important. Congratulations, everybody. Like I always say, these tests are hard. These tests would be hard for middle schoolers, even for high schoolers, and probably there are a couple questions on here which college kids would scratch their heads with. Just the fact that you're sitting down taking this test is awesome, and I'm really proud of you. If you're getting some questions right, that is great. That just means you are that far ahead in math, and man, there is so much you can do. Great job, everybody. The next test will be December 17th, so I hope to see you then.